Okay, sir.
आप सभी लोग का इस मंथली साइंटिफिक इंटरैक्टिव सीरीज के 13वें लेक्चर में स्वागत है। आज का टॉपिक है emission source profiling in Indian context and emission inventory development। तो ये बहुत ही आज के परिप्रेक्ष्य में इम्पोर्टेंट लेक्चर है और इसका आज के डॉक्टर गाजला हबीब, प्रोफेसर डिपार्टमेंट ऑफ सिविल इंजीनियरिंग, इंडियन इंस्टीट्यूट ऑफ टेक्नोलॉजी दिल्ली के द्वारा इसको प्रेजेंट किया जाना है। ये अपने क्षेत्र में जाने माने रिसर्चर हैं और मैं अनुरोध करूंगा माननीय अध्यक्ष महोदय से कि दूसरा।
Good morning, everybody. First of all, I welcome Professor Habib for this lecture series. We are organizing this lecture series every month by the eminent scientists or leading expert in the field. This is the 13th lecture in this series. Dr. Habib will be talking about emission sources profiling in Indian project. In fact, if she can present some examples from Bihar or from military range that will engage in it. Now, over to Professor Habib for this introduction. Thank you.
Thank you, sir. Am I audible, clearly audible?
Yes.
Okay, so thank you very much. So my name is Ghazala Habib. I am professor at the Department of Civil Engineering at Indian Institute of Technology, Delhi. I completed my PhD on emission measurement, emission inventory development, and I joined IIT Delhi in 2008. Since then, I am working in this area. So today what I will present is actually a joint project led by IIT Bombay, but the main component of source emission measurement and emission inventory development, source profiling was done by IIT Delhi. So IIT Delhi was a coordinator of emission inventory and emission measurement. Here I am putting the list of the institute who were participated in this project for activity data survey in 4 sectors, which is residential cooking stove, brick kiln, open biomass burning, and on-road transport sector. So I'm just mentioning that these all institute participated in this project for surveying. So as we know that the emission inventory is a basic tool or basic input data in all dispersion model, regional and global climate models. However, it is well known that emission inventory for especially South Asian region is incorrect, and therefore Southeast Asian region, including India, is incorrect, and therefore the simulated properties of particulate matter or aerosol is underprotected by the model. And there are many other reasons also, but one of the reason is the emission inventory and basically the emission activity data and emission factors are responsible for this underprediction. So here I have just portrayed some of the the underprediction between different model, or the inconsistency between different model, as well as the underprediction by model in terms of AOD or aerosol absorbing aerosol optical depth. So why, therefore, we know that the correct source profile, correct emission factor, and representative activity data, that is fuel use estimate, is necessary to have a representative emission inventory, and therefore to even upgrade or update the modeling activity, not only at local level but regional and global level. So with this, I would just mention the important sectors in context of Indian region, and what are the methodology that have been adopted earlier and what is new in the methodology which we have refined. So these are the sectors important to Indian region: industries, transport, residential sector, agriculture, and informal. However, there are different technologies in each sector. We all know that, for example, in industry, thermal power plants are very different than other heavy and light industry. Then technologies like PC boiler, each technology has some kind of emissions. Similarly, in transport sector, we have on-road transport, railway, shipping, aviation, and various technology. Number of technologies are widespread in India, and it's regionally, different in various part of Indian region. So residential sector, cooking and non-cooking activity, means lighting and space heating. Both, all three are important. And various devices are used: traditional stove, biomass, LPG stoves, kerosene stoves, and so on. Similarly, for agricultural sector, agricultural residue burning is one of the major, problem in North Indian region. And agricultural, devices used like diesel use in off-road vehicles are another problem. Informal industries like big production, food processing, they are also, one of the important emitter of aerosol and gaseous precursor of aerosol. And there are various type of brick kiln existing various other, means many states of India, means lakhs of brick kilns are there, and some are registered, some are not registered. So if we want to address the emissions from these sources, we have to take not only the technologies into account, but also we need to think what should be the level of data collection for each technology, because technologies are different, their working principle are different. So therefore, a tier 3 approach, which is updated approach from tier 1 and tier 2. Tier 1 and tier 2 are basically just takes one fuel consumption, which is reported by government bodies or NGO, and multiply it with some emission factor, maybe from the same source or maybe from the other sources. And that is what the approach, followed in earlier or previous study. However, in tier 3 approach, the detailed activity or technology level information is needed, and measured emission factor for each technology should be used for emission estimate. So we followed the tier 3 approach as per IPCC, and therefore I'm just briefing here the 4 sector where we have refined the activity survey, activity data through field survey, and also the emission measurement using a new system developed by IIT Delhi. And here you can see the activity survey means even the biomass were weighed during the field survey, and various questions like how much acre of land is there, what they grow in various seasons, what kind of fertilizer they use, all these information were gathered. So similarly, for on-road transport sector, the mileage of the vehicle, the annual distance travel, annual average distance travel of the vehicle, how much fuel they use per week, how much distance they run per day. All these questions were asked. Similarly, for brick kiln, what is the production rate? What kind of fuel they use? How many times they, feed their brick kiln and so on. So the detailed questionnaire survey was done under this project, and emission measurement system, which is first time developed in India for field measurement, was done under this project. So I will just talk about, first I will talk about the emission measurement, source profile development, and so on. So here, what is the challenge? When we measure the gases, we all know the different gas molecule have their different structure, and it's well known. For example, SO2 or CO or CO2, we know the structure of the gas molecule. Therefore, it is easy to measure them using sensors, right? But aerosol are mixture of not a one compound. It's several compounds, several organic compounds, inorganic compounds, black carbon, trace elements, and so on, means trace metals and so on. So aerosol can, and their size, shape also varies, right? The aerosol could be from few nanometer in size up to 10 micrometer in size. It's a wide range. And also the shape, it could be, spherical, it could be of other shapes. So size, shape, its property, everything changes with the emission from various sources, depending upon what kind of fuel is being used, how much the combustion is efficient, and so on. So therefore, the measurement of aerosol is not easy. We have to simulate what is happening at source, and once the emission is going to the atmosphere, then the chemical processes which are happening and generating the secondary particles, that should be simulated in the system for correct aerosol measurement. So this is what we have done. So we took these challenges where we developed a system with low particle loss or negligible particle loss, sufficient phase equilibrium and residence time, so that the gas or VOCs can be converted into particle as it happens in the atmosphere, and correct emission measurement can be done. So here is the system. This system has three major parts. One is inlet, which are different for different sources, area sources, line sources, and point sources. Each inlet is designed, each type of inlet is designed for isokinetic sampling, low particle losses, etc., and the representative, to collect the representative sample from the field. The second part, I will just put the pointer. Okay, so this is the inlet part. Okay, this is the second part, which is the collection, the system for aerosol on filter papers. And the third part is, which is the heart of the whole system, is dilution tunnel. This dilution tunnel is designed by IIT Delhi along with the ejector to take a fraction of exhaust or the smoke from the field without having any power supply. So this works on negative pressure generation. I will show you here. This is a ejector which works on its own without any power. So what happens? We supply the zero air or clean air here and generate a negative pressure over here. So on the left-hand side of the particle sampling probe, the pressure is positive. Here the pressure is negative. Therefore, the exhaust goes through this particle sampling probe, and then a mixing of zero air and the exhaust takes place inside this dilution tunnel, and that allows the conversion of gases, VOCs, etc., into particle as it happens in the atmosphere. Then the fourth part is the real-time measuring equipment, ethylometer for black carbon, nephelometer for the scattering, OPS for particle number concentration, and CO2 to measure the carbon dioxide for calculation of dilution ratio. So how much we have diluted the exhaust inside the dilution tunnel. That is being calculated using CO2 after dilution and CO2 before dilution using the flue gas analyzer. So flue gas analyzer is used to measure the gaseous concentration in the exhaust directly, undiluted exhaust. So then the zero air assembly, which actually produces the clean air, particle-free, moisture-free, and VOC-free air for the dilution, is another part of the system. So here the photo of some of the part of the systems are shown. The filters are collected in this way. We can see that the filters are almost gray or black. So black in color after collection. So these are two dilution ratio, and this is ejector, which was designed by IIT Delhi. This dilution ratio is for wide range dilution. This is dilution tunnel for wide range dilution ratio 30 to 100. This was for 10 to 40 dilution ratio. Okay, so here, as I said, the different inlet was designed for different source. So the earlier inlet was for the area source, and this is for line source, means we can measure the exhaust from tailpipe during on-road operation of the vehicle. So the other part of the system is same. I'm not explaining the design of the inlet and all. It would be like too much for this talk. Here, I'm just telling you, designing a system is one thing, but we have to evaluate the system so that we know that what we are claiming, that the particle losses are minimum or negligible, and the mixing inside the dilution tunnel is very well mixed exhaust we are getting, or well mixed sample we are getting on filter paper, and also the complete quenching of gaseous phase species is taking place inside the dilution tunnel. For that, we did the evaluation inside the laboratory. Here I'm showing that the without dilution tunnel, the particle number concentration is shown by black bars, and with dilution tunnel or other component of VS3 versatile source sampler is shown by the hatched bars. And you can see there is no difference in particle number concentration, even if we put the one of the component, or we evaluate the one of the component. So three components, multi-arm inlet, which is this one. This was evaluated, dilution tunnel was evaluated, and also the central plume, plenum, which actually draws the exhaust, was also evaluated. And we have seen that there is negligible particle loss. The whole evaluation was also done for the diesel vehicle, gasifier, cook stove, and the consistent elemental carbon, which is actually primary particle, which does not convert in the atmosphere. It remains, it's an inert component of aerosol, remains same at various dilution ratio. That means that there were no particle loss inside the dilution tunnel. Also, the OC, organic carbon on filter, were almost insignificant change in organic carbon with increase in dilution ratio. That means the quenching was complete, and there is no loss of VOCs from the system. Okay, the residence time was also calculated. The residence time was always greater than equilibrium time, phase equilibrium time. It made sure that the quenching was complete inside the system. After doing the field laboratory evaluation, we also took the system in the field. This is one of the Dholpur, Rajasthan, and we evaluated the whole system over there, including all the sophisticated instrument, and we found out that the system correlated well. All the system, these five systems were designed, and fabricated and given to various institute, and all the system worked similar. So this is the field experiment we did in Bihar, and for residential cooking. And this is the system. This is power trolley. This is the trolley for the instrument. This is multi-arm inlet. And we completed almost 80 experiments in Bihar for cooking, water heating and water heating, space heating, open biomass burning. So total 100 experiments. And this is some of the pictures from the field experiments. So this is again the system which is used for measurement of tailpipe emission from tractor, truck, and LMV good vehicles. And the similar kind of similar experiments we have done for light duty vehicle in Delhi, but it was under DST project. So that was completed in 2016-17. So these are the experiment for heavy duty vehicle. You can see the whole system, how it is, put in the truck, and the experiments were conducted. Then the sample or aerosol sample collected on filter papers, various filter paper, quartz fiber filter, PTFE means Teflon filter, Nylozor filter were used to analyze the for various component, including or elemental and organic carbon. The quartz filter is used for this analysis. Then Nylozor filter was used for ion chromatography to determine the water soluble ions. And one set of quartz filter is being analyzed for molecular marker and PAHs, polycyclic aromatic hydrocarbon. This is the gravimetric analysis facility where we weigh the filter before going for sampling or before field operation and after collection of the particle. And this is standard class 1000 facility, means very clean facility. We also did the source apportionment study at 3 sites, which is like Bikaner, Jammu Kashmir, and Mohali. The institute the University of Kashmir and ISAR Mohali collected the sample, and we did the chemical analysis for them. So here, the first result I am showing is source profile. I would like you to have very close attention to this. So here you can see the component, various component OC1, OC2, and water soluble ion, and the trace elements which are Na, Mg, sodium, magnesium, aluminum, silica, etc., measured on various filter. For firewood combustion in cooking stove are shown with yellow bar, gray bar, blue, pink, and so on. And so this is the source profile generated from emission measurement. The black dots are the source profile given by the PMF from the Bikaner source apportionment study. You can see it's like the source profile is very close or to PMF generated source profile. However, there are some elements given by the emission source profile are different than the PMF generated source profile. Now, what we do when the PMF generate any source profile, we actually judge the source profile based on some of the signature. For example, in case of biomass burning, the signature is pyrolyzed carbon, which is OP. Okay, one of the signature is pyrolyzed carbon, which is OP, which is always present in any combustion of biomass, any biomass combustion, wood, dung cake, or crop waste. The other is potassium. Potassium is one of the marker for biomass combustion. So looking at the profile, we thought it's a biomass burning. Okay, fine. But these black dots are showing that some of the components which should also be present in this, PMF generated source profile are not there. That means what? Means these components in PMF might have gone to other factors or other sources. So in order to refine this source contribution given by PMF, we have to play with the source profile generated by PMF and try to have some mass of calcium, magnesium in this PMF resolved source profile. For example, I'm just giving the example of calcium, magnesium. So similarly, we have to play with PMF factor so that the factor should match with the signature given at the source. Okay, and this will resolve actually the total source contribution given by any receptor model, especially PMF we are using. So that is what we are trying to refine. Similarly, for the diesel vehicles, I'm not going to explain this because I have already given the message which I want to give. Here, the emission factors, which is gram of pollutant emitted per kg of fuel burned, are calculated using the data, and you can see the PM 2.5 emission factor is 8 to 18 for different field. It's very high, gram per kg, EC and OC. However, if we compare these emission factors with literature, so this is literature and this is our emission factor. So our present study has higher emission factor than the literature. So what we did, we did the cluster analysis and took those emission factor basically which are from field measurement and which are close to each other, and used that average emission factor for emission inventory calculation, for emission estimate calculation. Here the total fraction of various components have been shown for different fuel type. And you can see that major components are carbonaceous aerosol, almost 50 to 60%, and rest are ions and trace elements. Similarly, for this is for heavy duty vehicle, and right hand side it's for light duty vehicle, and we have the emission factor for this two type of vehicle, technologies, and for PM 2.5, EC, OC, CO, CO2, NOx, even SO2, I have not shown here. So, and we can see the emission factor earlier, given by earlier study, were lower than the on-road measurement, because these studies were done in the laboratory using or following a specific protocol which may not be representative for Indian. I'm sorry, somebody was knocking the door. Okay, I'm sorry for that. So this is how for heavy duty vehicle also we can see the earlier emission factor has large uncertainty. So error bar, dotted error bar is for previous study, while this present study is very confined emission factor with like low error bars. Now, after that, the data collection, the activity data collection is another challenge for emission inventory refinement. And for that, we developed the questionnaire survey for each sector, depending upon the need of the emission inventory. And the emission, survey were done in various parts of India, almost 5,000, over 5,000 survey of residential sector, agricultural residue burning 2,400 survey, brick kiln 480, transport 16,000 vehicles were surveyed for transport sector. So all 17 institutes participated in the survey activity. So this is one of the figure for survey activity. So then now the challenge is how to use the emission factor and the survey data to have a representative emission estimate. For that, the methodology was developed for residential sector, brick kiln, open biomass burning, and on-road transport sector. I am not explaining each one, but basically the whole methodology was based on the government, the data reported by government, Census of India, National Sample Survey of India, and then what we have collected from the NCAP college survey. So this is some of the very interesting result from residential sector. You can see that the LPG usage has increased in present study is showing the LPG usage has increased in both in rural and urban area. However, in rural area, the fuel wood, dung cake, crop waste have decreased, but if you will go for this is the based on the per capita or per household consumption. Okay, so LPG usage has increased. This is what it's showing, right? Now, if we see the here we can say in this figure, the LPG consumption kg per consumer per year was too low compared to in rural area. It's too low compared to the urban area. Why? We found out from the data analysis that though there are LPG consumption in rural area, the LPG use is not that much. It's like 70% household are having the LPG connection. However, only 30% are able to refill the cylinder and use the LPG. So therefore, even though the government has provided the LPG connections, still the SBF means solid biomass fuel usage has not reduced. Total consumption has not reduced much, okay, compared to the earlier or previous study. LPG consumption has gone up from 9 to 19. If I just compare from the Pandey and Venkatraman 2014 inventory, but solid fuel consumption has not reduced much as compared to LPG, rise in LPG consumption. Okay, so therefore the emission was estimated for PM 2.5, OC, BCCO, CO2 and NOx for residential sector using the measured emission factor and the fuel consumption based on the NCAP survey. And this is the spatial distribution where, plotted using the proxy population as a proxy at 5 kilometer by 5 kilometer resolution. For on-road transport, the registration data of vehicle was used. The log logistic model was used to derive the fraction of vehicle on road compared to the registration, because we know that sometimes the vehicles are old, they are scrapped. Sometimes the vehicles from one state, come to another state, but registration does not change. Means they use the vehicle, but they do not transfer the vehicle registration number of the vehicle. So it's in such cases, the survival or the on-road fraction of vehicle would be very different than the city registration or registration data. So this survival model gives us the survival fraction of the vehicle on road. And using these two parameters and actually deriving this parameter from the NCAP survey, the national level, on-road population in 2019 was calculated, and therefore the national level fuel consumption was calculated. So some of the, results from the survey, you can see the super emitter survey was also done. Earlier, the super emitter was assumed. Super emitter means those vehicles which are emitting 2 to 3 times more than the new vehicle, a new or, well-maintained vehicle, you can say. For example, in our earlier study, we have seen that taxis are like 2 to 3 times more emitter than the personal cars, because personal cars are maintained well. So the super emitter survey was also done in 7 tier city, and here the fraction, you can see the fraction are very different. In T5, the fraction is highest, which is around 20%, while in earlier study, only 20% was used in all the cities. So this is one of the product of the survey. Then in different tier city, how many vehicles are surveyed is given here. Then from the survey data, we calculated the mileage of the vehicle, the annual average distance traveled by the vehicle, and this is plotted here for 7, 3, 3, 6, 3, 9, 11 vehicle categories. Okay. Then the fleet composition, on-road fleet composition was also estimated. Is how many of two-wheelers are there, and of which age group. Let's say from 0 to 5 year age group, 56% two-wheelers are of 0 to 5 years age group. Then 30% are of 6 to 10 years age group. So this is age-wise fleet composition was calculated. Then retirement time of vehicle, or when 50% of vehicle are retired, was calculated using the survey data, and one of the shape factor of this survival curve, alpha, was also calculated using the survey data. This is this whole information goes into log logistic model for estimation of on-road vehicle population. So this is on-road vehicle population, which is much more less than the registration data. So if we will take the registration data and calculate the emission, then we will overestimate. Okay, but we have to calculate the on-road population of the vehicle at present. So this is the fuel consumption: diesel, CNG, and gasoline. So diesel is the highest emitter or highest type of fuel consumption. This is more used in India, and diesel are used in LMV good, HTV trucks, buses, and others. While four-wheeler LMV passenger, they use gasoline and CNG. So this is showing the emission of PM 2.5, ECOC, CO2, and NOx from all these vehicles, and we can see the HTV trucks are highly, high emitter of all the aerosol species, right? Compared to four-wheeler, two-wheelers, and LMV passenger, basically because these three vehicles have higher, mileage, and annual distance traveled by four-wheeler, LMV passenger, and two-wheeler are less compared to LMV goods, HDV trucks, and buses. And emission factor is also high for HDV trucks and all. So after that, speciated multi-pollutant generator, SMOG, India database management system was built based on the emission factor activity data. This system gives the emission inventory at national, state, and city level. Here the picture of the system is shown. So the whole system is Python based emission inventory management system. The features are, it's very user friendly. The user can decide the base year of the inventory, the sectors, they can select the sector, they can select the state, district, and then village, not village, city, and so on. So at very high resolution, emission inventory or an emission estimate can be seen spatially, and the data can be downloaded. So this is the SMOG, where it's a query-based system. So whatever query you have, you can put that query and you will get the final output from the system. So here one of the video I will show you. So how to select the sector, all sector, energy, industry, transport, whatever sector you want, you can select the state, you can select the district, and then it will give you the PM 2.5 emission in teragram per year, and it will also show you the contribution of each sector in that region, and so on. You can also select the pollutant if you want for VC, CH4, NMVOC, NOx, OC, or SO2. So this is all. So basically the highlight from the whole talk is A versatile source sampling system has been designed, evaluated, and used in field for emission measurement of precursor gases and aerosol in a very, representative way. Various inlets have been designed for various sources. Then standard protocols for, storage, weighing, storage, gravimetric analysis, chemical analysis, and storage of the filter after collection, all are developed and is available. Updated fuel use in on-road transport, residential, open biomass burning, brick kiln have been estimated using activity survey data collected by 17 institute. I would just like to mention that the survey of other industries like power generation and other industries have not been done under this project, which we are doing in another project funded by West Bengal Pollution Control Board. So that we will do, and we will have a separate emission inventory for industrial sector of West Bengal. Then speciated multi-pollutant generator, which is MOG, India Database Management System, was developed, which would be available for public usage after like publications are out. And even anybody can contact me or Professor Venkatraman if they need emission inventory. The database is being updated for emission factors and source profile for all sources to ensure the representative of the database for India. Thank you very much for your attention.
धन्यवाद जी, आपने बहुत अच्छा प्रेजेंटेशन दिया और काफी फ्रूटफुल है।
मैडम कैमरा ऑन कर लीजिए।
ओके, ऑन है कैमरा। एक सेकेंड
ऑन है मैम।
हाँ,
प्रेजेंटेशन बंद कर दीजिए।
प्रेजेंटेशन बंद कर।
यस
madam, excuse me. Very nice presentation from your end with respect to the source profiling with the Indian context. One thing that I observed that you have been mentioning that emission factor for different residential sector that was some deviation from the established emission factor from your observed values. So which data you taken into consideration for while calculating the emission inventory?
Yeah, so as I said, we are not rejecting the previous studies. What we are doing the cluster analysis. We are taking all the values and doing the statistical cluster analysis to see the clusters which have most of the values and have less than 50% uncertainty on average. And mostly the value should be of field study. Generally, field study have very, close values. There are few field studies for brick kiln, I think, and residential sector published by other groups. However, for on-road transport, other than IIT Delhi, nobody has published the emission factor from on-road measurement. So we are doing the cluster analysis to have a representative emission factor. We are not saying the other emission factors are wrong or we are only right. All those things, we are not making any claim like that.
Next one is that you have given the very few components with respect to the source emission. As far as our city especially action plan is concerned, we have to prepare the action plan based on the emission inventory. So that considering our city total air pollution of the city, that is a output of the different kinds of pollutants like road dust, industrial sector, automobile sectors, that is the garbage burning. There are so many issues concerned, sources are there. So considering that is the total source emission inventory in this particular city, this all the system that have been developed by that is the DS3 can be used this way garbage burning system.
Yes, the system we have developed can be used for garbage burning emission measurement, which is area source. So we have a different inlet for area source. regarding resuspension of dust, this system cannot be used for resuspension of dust measurement because along with the resuspension of dust, we means it's during the on-road operation of the vehicle, you cannot have the resuspension of dust from one vehicle. So it's a mixture. So IIT Delhi is taking a task to design a system where we can measure the resuspension of dust from individual vehicle along with the non-tailpipe emission, including the emission from brake wear, tire wear, and so on. That we are, intending to do in future. However, this system cannot be used for resuspension of dust emission.
Thank you, madam.
Rajana, madam, thank you so much.
I have one question, madam. While I was going through some literature on emission inventory, I could see different scopes of emission, which have been developed by the GHG protocol. Will you give some light on these scopes of emission?
On GHG, greenhouse gases, right?
Yes.
Okay, so greenhouse gas emission inventory has been developed by many research group in India as well as in international groups. However, I have not worked on GHG emission, but I can say that GHG emission, according to IPCC, it's very well known. So it's very constrained emission. So even IPCC says that we don't have to revise those emissions because, as I also mentioned, that CO, CO2, all gases are having a specific molecular structure, right? So their measurement is very easy. You can measure the gases from sensors, and it's very consistent. So GHG emission inventories developed by various groups are having very good set of emission factor database and activity database, and therefore the emission is very reliable. However, in future we can do the assessment of or revisit the previous estimate and see if there is any difference or any discrepancy.
Madam, just one more curiosity from mine. Just as per the guidelines of the CPCB, they are given the methodology defined for the different kinds of pollutants to be monitored in the while emission inventory. And based on your observation, that flue gas analyzer and other that system developed by you. So, what is the difference between the observation? Have you observed some observation with respect to the from the conventional methods of the methodology being adopted by the as per CPC guideline for the emission inventory, and based on your system developed by that, we suppose that PM 2.5 or PM 10 is a particular for particular PM 10 or PM 2.5 value with respect to the CPC guideline and with respect to your value. What is the deviation? Have you measured or have you have comment on that?
CPCB. Can I, just I want to be clear what you are asking. Do you want to say that the protocol given by CPCB for measurement and the protocol developed by us, are they different? And have I observed any difference in
system developed by the that is the methodology given by the CPC? And based on that, suppose that someone is calculating the emission inventory based on the methodology given by the CPCB for different parameters, and someone is calculating the emission inventory based on your methodology or a system developed by you. What sort of deviation may be there?
Okay, that depends upon the level of information used by the other group in terms of activity data and emission factor. So I cannot say they would be different or not. I can't make that comment, but yes, it all depends upon the level of activity data taken into account, and also the emission factors measurement, standard protocol of measurement, analysis, all will, matter in emission inventory development. So it may be different. I can't say how much, but it may be different.
So, madam,
Yes.
the thing is that now there is the CPCB protocol developed about 10 years back. Now the information knowledge has increased many times during this period. So, is it not possible to recommend the either methodologies for development of emission inventory or the source enforcement or the benefits of EMF, what you have described, so that the more and more species are being identified for the mitigation measures? Is it not possible, or we are not supposed to? IITs generally, the CPCB takes the help of IITs also for upgrading their knowledge. The national information also they are sharing. So, what is the feedback of CPCB?
What is the feedback of
Feedback of CPCB.
Feedback.
CPCB? Feedback of CPCB on new knowledge and information we have gathered or emission inventory. This is what you are trying to ask?
Yes.
See, the first part of your question, which was like, can we, update or revisit the protocols laid by CPCB for emission inventory and source support? That was the first part, right, Dr.
Yes.
Saha? Okay.
Yes.
So I definitely think that we should revisit the protocols developed for emission measurement and source apportionment laid by CPCB, because there are much more update, as well as there are new researchers who have, done their whole PhD in source apportionment from abroad, even from national institutes. And when I was working with this NCAP group, the source apportionment was laid by Professor Ramya Sundar Raman from IISER Bhopal, and emission inventory was laid by IIT Delhi, me and Professor Venkat Raman from IIT Bombay. We have felt that the protocol developed by Professor Ramya Sundar Raman for source apportionment and for source characterization by IIT Delhi is very different than CPCB protocol, and it has more detail and a very specific detail about what, like, even setting or selection of the sites for source apportionment, setting up the instrument, gravimetric analysis, then chemical analysis, storage of filter. There are differences in what was done earlier by CPCB or what we have in our protocol, and it was minutely, very, thoroughly done exercise, documenting each and every point, and even the troubleshooting was documented under this project. So I think there should be the committee to revisit the protocols laid by CPCB, and new researchers should be involved who have already worked or working in this area.
Yes, that is the workshop. Brainstorming is required at the national level. So
Yes.
that we should have the right methodology for doing the right approach. Is this correct?
And update it.
Exactly. And including the updation of your emission factor that we have developed in Indian context. Because in CPCB, they are developing some of the emission factor, and most of them taken from the 1848. Maybe 42, madam? Maybe 42 is taken care, but we should have our sector-specific emission factors in Indian context. To my opinion, if we carry out even the assessment task in Delhi and in Patna, there will be emission difference, the emission factor difference will be there, because the road condition, the soil condition, the tire abrasion, everything will vary. So even for the region specific emission factor is required. Otherwise, if you are applying the same formula for the entire country, it may not be the correct judgment and may not be the right judgment for the rationality for the science, because ultimately we need forward for the science. What science says and what nature does, these are required to be combined with the natural condition. This is one of my personal requests to all of you, because you people are involved in this. Another aspect, madam, we are, the Indo-Gangetic plain is suffering from intrusion of dust from the transboundary movement of that. Could you please tell about our publication that we did with me and you all prepared along with your students about the trajectory analysis something?
Yes, so we have done the trajectory analysis for 3 sites, Jammu Kashmir, Mohali, and Bikaner, and also Delhi. And we have found basically in Mohali and Delhi, most of the time or most polluted time of the year, which is winter and post monsoon, the air mass comes from northwest direction. And basically the secondary formation of aerosol is more dominated than primary emission. Then during monsoon, pre-monsoon, and even the post-monsoon season, the resuspension of dust play a major role in enhancing the aerosol concentration over this region. So I have not presented the source apportionment part of the study. However, I'm agree that what you said is absolutely right. The trajectory analysis, the source apportionment analysis study, they all should be, as I told you, in PMF source profiling and the source, the profiling at the emission measurement source, they relate to each other, but they are not correct. So we have to work in 3 levels: source apportionment, the source location by trajectory analysis and so on, and clubbing the information of from source apportionment and emission measurement together to refine the emission inventory further, and source apportionment also. So you are very right that this whole thing should be integrated at the finally, and the trajectory analysis and all should be done.
I have one request from Bihar State Pollution Control Board. You please share your presentation to us and the standard protocols for of samples, etc. You share with this board. We will be really thankful to you. And then we look forward about this MOG that also we can develop our.
Yeah. So I can share my presentation. The SOPs was developed under NCAP, and I have to either you can write to Professor Venkatraman for SOPs, because I'm not the whole authority to share these documents. It's collective effort, so I cannot promise on that. Do you understand what I'm saying?
One thing I just do hereby contradict. Whatever we are developing for the country. And why there should be hide and seek?
No. It's not hide and seek.
The knowledge cannot be shared.
For communication, they don't want to share.
No. Don't get me wrong. I'm not saying it cannot be shared. But IIT Bombay was the lead institute, and Professor Venkatraman will decide how to share and when to share. I cannot promise from my side.
So that we get a copy of that protocol.
Yeah, you can definitely write to her. She will definitely help you in providing SOP for source measurement. We have, because IIT Delhi has developed that, we can share. But SOP for chemical characterization developed by Professor Ramya Sundaraman is with Professor Venkatraman, Professor Ramya Sundaraman. I can use it. The protocol I can use it, but I cannot, promise for sharing.
Whenever you are sharing at the national level or public.
I will definitely, sir. Yeah.
Online.
Online, sir, what?
Any speaker from online. Anyway.
Thank you, Dr. Gajal. आपने बहुत अच्छा प्रेजेंटेशन दिया, और एक चीज हमारा भी जानना था कि जो AP 42 में जो फैक्टर्स दिए हुए हैं उसकी जगह क्या हम PMF को यूज कर सकते हैं?
सर मेरा तो मानना है कि हमें PMF और CMB दोनों को स्ट्रेंथन करना चाहिए अपने रीजनल सोर्सेस के लिए। अगर सोर्स अपॉर्चनमेंट को हम मतलब एक्चुअली कहना चाहिए रिप्रेजेंटेटिव बनाना चाहते हैं या कहना चाहिए कि मजबूत करना चाहते हैं, तो हमें CMB और PMF दोनों को साथ लेके चलना चाहिए। Because now we are having the source profile from emission measurement. So we should see if both model works in a similar way or they produce the same result or the results are different. And if they are different, then how to make, how to optimize the model with the measurement. That is what we should focus on.
Also, or it can be complementary for validation of the model. That
Yes.
also, yes. It will complement if we do it taking up the both and then we validate each other. That will be both useful for the science.
Yes, sir. Yes, sir.
Thank you.
Thank you. Thank you for giving me opportunity to present this work, and I'm really happy to, interact with all of you. And
Actually, our member secretary wanted your visit to Patna because we are going for developing a sophisticated laboratory, air laboratory, research laboratory. Rather, it is a research station for air. So our chairman is there, and our member secretary was very keen so that we can visit once to the Patna, and we can have interaction because the building is under construction and the laying of the laboratory and the procurement of the instrument, your support and help will be very much required.
okay.
Because you are number one in the country about the instrument, about emission inventory, about source apportionment, and I had the West Bengal Pollution Control Board. She is the and I know her since.
In fact, we are establishing a sophisticated air pollution laboratory here. So we want and how to procure equipment, what types of equipment is required. All these want to help.
Yeah, I would be happy to help in this matter. I think whenever generally we have a good time during semester break or maybe in vacation. So the semester break is here. The semester break generally in October, September end or October. If you want, I can manage to come during that period. Let me know your availability and convenience.
Thank you. आपके
Thank you very much. Thank you. Thank you.
क्वेश्चन के लिए एक बार प्रेजेंट के लिए धन्यवाद। माननीय अध्यक्ष महोदय की इजाजत से सेशन को
Now, close the session.
सेशन को कंक्लूड किया जा रहा है।
Thank you, sir. Can I leave now?